Right, so comprehension is very important. Understanding what exactly is happening in the question, right? So I like the questions that follow. In fact, I think there's a question that I might just add. JH. They don't ask us to find JH, but I think I'm gonna make a video where we find JH. Okay, that concept is very important. Okay, again, that concept is extremely important. So I'll explain in one of the videos how to find JH. But for us now, we are finding FG. FG is over here. Okay, what is FG? FG is the difference between this point and this point, right? As the distance between these 2 points. Again, the difference between those 2 points. So we need to know what the y value is here and subtract it from the y value over here to find that distance. Okay, so just think about this quickly. Uh, the the distance between the two graphs constantly change. So over there's a certain distance between the graphs. Over here, there's a certain distance. Over there at FG, there's a certain distance. Over there's a certain distance. The distance between the two graphs constantly change, right? If we go inside, there's a distance over there's the distance over here, there's a distance here, there's a distance somewhere there's a distance even when there's going to be 0. So there's constantly a distance between the two graphs, and because it's a changing value, the distance is going to have a variable in it. Okay, because there's because it is constantly changing. If you find the distance between your two graphs, it's going to have a variable in it. It's going to be expressed as an equation. Okay, so we'll see what that looks like in a moment. But in order for us to find this length over here, we need to know the distance between the two graphs. How do you find the distance between the two graphs? You take the one and you subtract the other one. Okay, which one are you going to subtract from which? It's going to be the top one minus the bottom one. So if I'm here by JH over there, I think I'm going to deal with JH also in this video. Okay, if I'm by JH, then it's going to be the parabola minus the straight line because the parabola is on top. Here at FG, it's going to be the straight line minus the parabola because the straight line's on top. Okay, so they tell us in this question that FG is 12 units. Okay, we need to find this length, so we just need to find the x value, because if you have the x value, then you'll have the length of OL. Okay, but they're telling us that FG, which is the distance between the two graphs, is 12 units. So let's go take the straight line equations up here. Let's go take the straight line, which is g of x, and we are going to subtract it from the parabola, which is f of x. And in this question, they are telling us that the difference between these two at this point is 12 units. So I can go and say this is 12. Okay, so we are subtracting the two equations and we end up with a 12. So let's continue with this. G of x, what is g of x? G of x is the x minus the 3 minus f of x. So f of x is this whole thing. Remember to put this in brackets because that negative in front is going to change all of our signs. Okay, so this is going to be plus 21. All of this equals 12 once subtracted. Okay, so this negative goes inside, changing all of our signs. So this is x minus 3 plus x squared plus 4x and minus 21. And let's bring this over, so that is going to give us minus 12. All of this equates to 0. Okay, so let's see, this is going to be x squared. This over here, these are like, so that's 4 plus x is going to be 5x plus 5x. Right, this is 21 minus, well, minus 21 minus 12, that's going to give you minus 33 plus, oh, well, minus another 3, so minus 36 equals to 0, right? So all three of those were like, so you end up with this. Let's factorize this one. Okay, so this is going to give us an x and x. Factors of 36, right? So 36, what are the factors of 36? That is 1 and 36, 2, 18, 3, 12, 4 and 9, 5, no, 6 and 6, 7, no, 8, no. Okay, so you've got everything. We need a 5, right? So we look at these, 4 and 9. That will give me a plus 5, so a 9 and a 4. I need a positive 9 and a negative 4 to get me that positive 5. So let's go this one over here. This is going to be x plus 9 equals to 0. Subtract 9 on both sides. So this will give us x equals to a negative 9, and on this side x minus 4 equals to 0. Add 4 on both sides, so x is equal to 4. So what does this tell me? This tells me there's two places where the difference between my functions when my straight line is on top of my parabola is going to be 12. So this one over here will be 1, but somewhere over here on the left hand side there will be another place where the distance between the two graphs is going to be 12 units. Okay, so the one obviously on the right hand side is going to be 4. So they tell me, so we have found out rather that the coordinate of L is 4. So the distance from O to L is going to be 4 units. Okay, so OL, that is 4 units. That's what we found out in this question. Okay, so I did say I want to deal with let me get rid of all of this quickly. I did say that I want to deal with the distance between J and H and J. Okay, so now understand this. The distance between J and H is just the distance between the parabola and the straight line. Okay, it's not necessarily at this particular point where you see it. Okay, so maybe it is there, maybe it's not. That's not the point. The point is that somewhere there is this line that is in between the functions. So the question will be, and I didn't ask it here, I don't think I did, but the question will be, what is the maximum distance that JH can be, right? So over here, I'm just giving random numbers. Maybe over here it's 1 unit. Maybe over here it's 2 units. Maybe over here it's 5 units, whatever. Right? Maybe over here it reaches a maximum of 6. Maybe over here it's going to go smaller and smaller and smaller again, right? So the distance between these two graphs constantly change. At some point it reaches a maximum, okay? And then obviously it's going to go smaller and smaller and smaller again after that. How do you determine the maximum point, or the maximum length, the maximum distance between your two functions? Okay, so this is how you do it. You take the one that's on top. Okay, so in our case the one that's on top is our parabola over here. So the parabola, so it's f of x, and you subtract the one that's at the bottom. Subtract g of x. Okay, and when you subtract these two functions, they are going to create a new function. Let's call this thing m of x. It doesn't really matter what you want to call it. In fact, we should have called it jh. Okay, so we want to find this, and what is this? This is the distance between the two graphs where the parabola is on top of the straight line. Okay, so let's go plug all of our things in here. So parabola, that is minus x squared minus 4x and the plus 21. Great. The straight line is minus, so let's remember to put this in brackets. It's minus x minus 3. Okay, so let's just clean this up a bit, multiply this in. So this is minus x squared minus 4x plus 21. That's going to give you a minus x, and then that's going to give you a plus 3. Okay, so let's just see here. We have some like terms, that one and that one, and this one and that one. So this is minus x squared. This is going to be minus 5x. I think that was a 21, so 21 plus 3 is going to be 24. Alright, so now you have this new equation over here, right? And this is a function. This function describes the distance between your parabola and your straight line. If you draw this, okay, what you can see is that a is a negative value. So if you draw that, it's probably going to look something like this, right? This doesn't matter, just randomly went through there, but it looks something like that. Sad face parabola, a is sad, a is negative. This graph reaches a maximum somewhere. The maximum of this graph, okay, will tell you the maximum distance between our two graphs. So how do you determine the maximum of this graph? How do you determine the max? Okay, so I'm giving you a second to think, and now I'm going to tell you. You determine the maximum point of that function by finding the y value of your turning point. So we have options. One, we can complete the square to find the maximum value, or we can find the x value of the turning point with x equals minus b over 2a, and then find your y value. But I think for this video, I think let's go and complete the square, because we haven't done that in a while. Okay, so let's go with m of x. That's what I decided to call the difference between the two graphs. I need to first get rid of that negative, so I'm going to say minus. I'm going to open a bracket. I think I want to use a square bracket now, and this is going to become x squared, and I'm dividing this also by my x, so it's going to, well, my negative rather, so it's plus 5x. Okay, what did I just do? I took out negative as a common factor between my first two terms, right? And now this plus 24 thing that's here, I'm just going to leave it right there at the back. Let's put this in another color because it wasn't originally in the question. I'm going to add and subtract something, right? So we should know what you're adding and subtracting. You're adding and subtracting half the middle term squared. So my middle term is a 5, so it's 5 over 2. 5 over 2, right? What did we add and subtract? Half the middle term squared. Okay, great. So now we know that these three produce my bracket squared. Okay, let's go back to black. So this is going to be negative. I'm going to still have my square bracket here. I'm going to have a complete square. These three terms generate my bracket squared. So the square root of this one is going to be x. The thing inside this bracket, so it's going to be plus 5 over 2, goes inside there. This compensates for these three, but I still have this thing over here, so there's still this minus. This gets squared, so I'm going to simplify that. 25 over 4. Still have the square bracket and the plus 24 that's over there. Okay, now I want my negative to go inside, so it's going to multiply with this first term. This whole thing is a term, and then it's also going to multiply with that one. Okay, so now I have minus open bracket x plus my 5 over 2. All of this gets squared, plus the 25 over 4 plus my 24. Okay, so we can add this together. I'm just going to go use my calculator. I rely on the calculator for that. 25 divided by 4 plus 24. Calculator says 30,20, or 25 rather, minus x plus 5 over 2 close bracket squared. I added these two together, and calculator said it is 30,25. Right, so now let's make sense of this quickly. What is this? We've now completed the square, right? We completed the square of that equation. We said this equation over here was the distance between your two graphs when the parabola was on top. So this over here describes the distance between your two functions when the parabola is on top, and we have a certain p value and a certain q value. Our p value is minus 5 over 2. Our q value is 30,25. The q value is the maximum distance between your two graphs. So if I asked for the maximum distance of hj, you would tell me that it is 30,25. Great, that's a very nice question.